day-to-day version of the world emerges from this kind of subatomic reality. All of that fuzziness, all of that uncertainty in the quantum world, just how does it end up giving us that comfortable, familiar solidity of the normal world? At the other end of the spectrum, the solar system and beyond is beautifully and accurately described by a different equation: Einstein's general relativity. This remarkable equation tells you about gravity, about the warping of space-time, about general relativity. And when you take these two together, these two single mathematical sentences, they're enough to tell you everything you need about the fundamental behavior of the universe and everything in it. There is nothing more articulate than mathematics. Maths seems to be written into the physical universe. So on the one hand, at the teeny tiny scale, the standard model of particle physics does this amazing job. And in the ginormous scale, general relativity, you couldn't ask for anything more. There's just one problem when you try and put these two together. They're incompatible. The problem is that general relativity breaks down in the quantum world. Gravity simply doesn't apply to particles at the subatomic scale. Meanwhile, quantum effects are virtually never seen at the scale of humans and planets, where gravity rules. You and I are never in a superposition of existing and not existing at the same time. So what does this mean for us? Are there two different worlds, each obeying their own set of mathematical laws? Solving this conundrum is one of the biggest problems that puzzles scientists today. Will we ever reconcile the two?
I think it's perfectly plausible that within our lifetime, maybe somebody watching this program, will discover the mathematical structure which unifies Einstein's theory of relativity with quantum mechanics and just provides a perfect description of this world. And that would be really exciting.
Will we have one? How do I know? We would all like to have one. But, maybe we are not smart enough to formulate a theory that combines everything. It's hard.
I do believe that there are good ideas out there, and that eventually, it might take a long time, but eventually humans will work this out. I'm confident about that.
So will we make it all the way to include all possible forces at all possible scales with all possible forms of matter? It's a hope I have for our species, and that's all I can say.
The incompatibility of these two great theories, general relativity and quantum mechanics, creates a serious obstacle for believing that maths is really discovered. And there's a bigger hurdle to come. Many of the best proposals to unify general relativity and the quantum world have consequences that are even weirder than the problems they are trying to solve. They predict the existence of multiple universes. This idea is rooted in the mathematical explanations of the quantum world and the work of its founding father, Erwin Schrödinger. The mathematics in Schrödinger's equation insists that particles can exist in multiple states at the same time. And Schrödinger himself says that these possibilities aren't just alternatives, but really happen simultaneously. This can lead to multiple universes, and the maths also suggests there's an infinite number of them, each slightly different from the others.
Thank you.
Mathematically speaking, in an infinite universe, everything that's possible has to happen somewhere. Yep, that's right. Everything possible happens somewhere. Even Schrödinger acknowledged that the consequences of his equation describing the quantum world might seem lunatic. But if there's one thing I've learned, it's that you should trust the maths. So maybe our experience isn't special. Maybe our reality isn't unique after all.
There are so many distinct avenues of investigation that lead to the possibility of a multiverse. From our studies of unification and string theory, from our studies of quantum mechanics, even from the study of space going on infinitely far, even that gives rise to a version of the multiverse.
If we're going to reject everything that just seems weird, we're almost guaranteed to reject the true theories of the future when they get discovered. I think we should just chill out, accept that the world is weird, and that's just part of its charm, and trust the math.
So why does all of this matter? Well, if maths really is discovered, then there is an intrinsic truth behind the maths we uncover, however weird that truth seems to be. If math is invented, then how do we know what is true or false? Is it true purely because we define it so? And how does it relate to the real world that we all experience?
368 look good in the full dress mode.
In this series, we've seen that maths can explain so much of our world, from aerodynamics to planetary orbits, from the subatomic world to processes crucial to life on Earth. And that is something I just can't accept as a coincidence. So here's my take on things. For me, it's almost as though you have this alternate, parallel mathematical world that hides just beneath our own. You can't see it, you can't touch it. The only way that you can explore it is by using the language that we've invented. All of those symbols and equations and conventions are our only tools of navigation, and they are undoubtedly man-made. But once you're inside that world, once you're exploring the landscape that mathematics has laid out in front of you, I am absolutely convinced that you are on a voyage of discovery. It is a world without a human designer. So ultimately, I think it's both. Mathematics is a little bit of invention and a lot of discovery. Mathematicians will probably never all agree, and maybe we will never find a definitive answer. But the consequences of having that debate is why it really matters.
We have used mathematics for a much deeper understanding of nature and of the universe in general. We know about the universe now things that a few hundred years ago people didn't even know what to ask.
Searching for the truth about maths has, over 2,000 years of history, transformed the human experience. Discovering patterns everywhere in nature has given us structure, beauty, and inspiration. Inventing new areas of maths has led to an explosion of technology that ultimately underpins modern trade and computing. We have discovered powerful rules that we continue to use to explore, enhance, and explain the world around us. And we have had a tantalizing glimpse of what could be to come.
It's quite possible that what we have been doing in science for all these centuries is, in some sense, looking for our keys under the lamppost. We have been able to use mathematics to describe what happens out there, but that could be the tip of an iceberg of reality that we, as yet, don't have any understanding of, haven't yet had any contact with.
But most of all, I think that asking questions about the origins and truth of maths has given us a purpose. It's given us understanding. Ultimately, maths has given us meaning.